Hey, Izzy, what's the cooler for?
Hey, Zoe, I'm just icing down some drinks, For absolutely no one. Zoe, what are you doing?
I stepped on a crack in the sidewalk and hurt my ankle.
You tripped on a crack? You better call your mom to make sure she's okay.
She's fine, Izzy. Why are there so many cracks in the sidewalk anyway?
Hey guys, remind me not to drink anything from that cooler.
Zoe hurt her ankle from a crack in the sidewalk, and she's using the cooler to ice it down.
Sorry to hear that, Zoe. If it doesn't get better soon, we should take you to see someone.
Dr. Jeff, do you know why there's so many cracks in the sidewalk? They're everywhere.
Actually, it's from a natural process called weathering.
So weather causes it?
Kind of. Let's dive in. I'm Dr. Jeff Innicker, and today we'll explore the science of weathering and erosion. We'll look at how the Earth's surface gets broken down through weathering, how those pieces get moved through erosion, and how the pieces end up somewhere else through a process called deposition. With Dr. Jeff. Welcome to Labracazam, where we make science make sense.
Dr. Jeff, you said that the cracks in the sidewalk were caused by weathering. What is that?
Weathering is when the Earth's surface is broken down into smaller pieces. Then, those pieces are moved in a process called erosion and deposited somewhere else.
Wait a minute. Let me get this straight. So you're saying that the cracks in the sidewalk are caused by weather breaking it up?
Well, weathering is the term we use to describe the process. But there are many things besides weather that break up the Earth's surface.
But how could you break solid rock?
Great question, Zoe. Let's break it down. Let's look at some models of how weathering works. Since we'll be working with powerful tools, we're wearing our goggles and our gloves. Don't try this at home. For this part, I'm going to need a sock? Wait, what? Bert, that's not what I asked for. Oops, that was my favorite pair.
Dr. Jeff, I'm sure you have what you need in your lab coat.
You're probably right. A lock? A clock? A brock? Ah, here it is. A rock. Now, what's something that could easily be carried by wind?
Maybe sand?
That's right. Wind can throw sand and dust against rock. To show you what that can do to a rock over time, I'm going to use this sand blaster. This will create the effect of powerful wind with tiny pieces of sand in it. But as you can see, this is about to get very messy, so we got to go outside.
Whoa, the sand and wind work together to cut a hole in the rock.
And it happened really quickly.
Sometimes weathering happens fast, especially to softer substances like soil. But it usually happens very slowly, over hundreds, thousands, or even millions of years. Can you guys think of anything else in nature that could break down a hard surface like this?
Well, it rained yesterday. Does water cause weathering?
It sure does. Water is actually one of the most common causes of weathering.
We use water all the time, and it seems pretty harmless. How powerful could it actually be against a rock?
Let's find out using this water blaster machine. It uses just a stream of water to cut through hard objects.
No way this will work. I've used a water gun before. Needless to say, I've never split anyone in half.
Well, when water has enough pressure, let's just see. Back outside we go.
Now that's what I call a watermark.
To do this, we used a high-pressure water stream. But even water flowing slowly over long time periods can shape rocks.
It can also make rocks smooth.
Or even create entire canyons.
Besides the weathering that happens from flowing water, it also happens from water in a different form, ice. We'll demonstrate that using this metal pipe. Izzy, could you please fill this pipe completely full with water by submerging it?
You got it.
Perfect. This pipe is completely filled with water. Now, we're going to tighten it up. Next, we're going to put it into liquid nitrogen. Here you go, Zoe. We'll also need this safety shield. Go for it.
I remember liquid nitrogen from another demonstration. It's extremely cold and causes things to freeze really quickly.
Oh, that was awesome! You were right about the liquid nitrogen, Zoe. It causes the water inside to freeze. Then that water expands, causing the pipe to crack.
I've heard of this happening in people's houses during the winter.
I can see how this would affect rocks. When water gets into the crack and freezes, it expands, causing the crack to either get bigger or even the rock to break.
Labracazam. The types of weathering we've demonstrated here are the ones we can do in the lab, but there are other ways too. Like when plant roots grow into cracks, it causes rocks to split.
Kind of like a wedge being driven into something.
Also, gravity can take a toll on things over time, as seen in landslides. So now that we know how things are broken apart, where do the tiny pieces of Earth's surface go? I know they didn't just disappear.
Great question, Izzy. Weathering breaks the Earth's surface down into smaller pieces, and then erosion moves those pieces until they're deposited somewhere else. I can show you wind erosion using this compressed air to simulate the wind. Flowing water also moves pieces of the Earth's surface.
So this water flow causes erosion because it's moving in small pieces.
Yes, and it's depositing the pieces over here where the water flow ends.
Glaciers can also move pieces of the Earth's surface with them as they slide.
That happened fast, but in real life, glaciers are huge and move very slowly, like this one in Norway.
It seems like the same forces of nature that break rocks apart, like wind, water, and ice, also move them.
Labracazam. Weathering, erosion, and deposition work together. Weathering, it breaks it down.
Erosion, it's moved.
Deposition, it ends up somewhere else.
Let's look at some natural landforms and see if we can figure out how the material is broken apart, moved, and deposited somewhere else.
The Grand Canyon. It was carved by the flow of the Colorado River over millions of years.
Mushroom rocks. These are created by wind erosion. The wind carries sand close to the ground, carving the bottom more than the top.
I know this place. It's Split Apple Rock, New Zealand. It was created by water freezing into ice, the same thing that caused our pipe to crack.
You might not realize it, but you see effects of weathering and erosion every day. Let's check it out with some real-world science. Earlier today, Zoe tripped on a crack in the sidewalk. Every day, the concrete gets heated and cooled by the sun. The heat causes the sidewalk to expand, and when it's cooled, it contracts. If you do this over hundreds and thousands of times, the sidewalk will crack. Sand on the beach is created from ocean waves pounding on rocks. Those rocks break down into the fine sand we enjoy today. Erosion doesn't just happen over long time periods. Sometimes, like with mudslides, it can happen very quickly. Mudslides are caused by moving water and gravity. Now, let's check in with Zoe with some do-it-yourself fun.
Today, I'll show you how you make a model of weathering, erosion, and deposition using a stream. First, we'll need some supplies: a baking tray with some sand, a few small rocks, a marker, and a water bottle. In one half of the tray, make a landmass with sand, making sure it has a slight downhill slope. The empty part of the tray represents the ocean. Next, use your marker to make your riverbed, starting at the top of the hill and emptying into the ocean. In nature, a riverbed is actually formed by running water. Next, place the stones along the riverbed. These stones represent boulders. To add flowing water to your river, use the water bottle at the top of your riverbed and slowly pour. You can see that as the river flows, some of the sand and rocks are being eroded and then deposited where the river meets the ocean. You can investigate to see what happens when you pour the water slower versus faster. Try it yourself to find out.
Thanks, Zoe. Now, let's review. Today, you learned that the Earth's surface is broken down into smaller pieces through weathering.
Small pieces of the Earth are moved by water, wind, ice, and gravity, which is called erosion.
And these small pieces are deposited in a new location through the process of deposition.
Finally, a nice clean cooler to ice down my drinks.
Ooh, Zoe, what happened?
After learning all about weathering and erosion, I can't stop looking down at the sidewalk. And when you only look down, you run headfirst into a tree.
I'm sorry, Zoe. Is there anything that I can do? Great. Now my drinks are going to taste like hair.
At least it's better than thieves.
Join us next time on Labracazam. I'm Dr. Jeff.
I'm Izzy.
I'm Zoe.
I'm Bert.
Remember,
Always question, always wonder.